Okay, number 13. We're getting there. The times that 100 customers spent queuing in a post office were recorded. The cumulative frequency diagram shows the results. So here we have the cumulative frequency diagram, and we've got our results here. Okay. Now, part A, how many customers queued for more than 15 minutes? And part B, work out the median queuing time. Now, whenever I see a cumulative frequency graph, I always put in the median and the upper and lower quartiles. So if we've got 100, the median, remember, is going to be at the halfway point. So this will be at 50. Okay, so I go to where we have 50. Okay, and I just hit the line. There we go. And then I drop that line down so that I can get a reading. Okay, so this will be my median. Now my upper and lower quartiles, okay, so 100 divided by 100 divided by 4, which would give me my quartiles, would be 25. So at 25 I have my lower quartile. Even if they don't ask for it, I will put it in. And my upper quartile will be at 75. Okay, so you go along until you hit the line. Well, it's a bit wonky, but it's close enough for rock and roll. And I now drop those lines in. Okay, so this is my lower quartile, this is my upper quartile. Okay, I always put them in. Inevitably a question will be asked, or if it's not asked, it's good to show the examiner you know what you're doing. So now we can go back to the first question. How many customers queued for more than 15 minutes? So here we have 15 minutes. So I draw a line from 15 minutes and I go up until I hit the line. Okay, and then I come across. So here I can see there at 80. Okay, now 80 people took less than 15 minutes. Okay, everybody in this area here took less than 15 minutes. Okay, because if it was 10 minutes, you'll see it's in this area. If you've got 5 minutes, you'll see it's in this area. So 80 people took less than. Okay, but we want how many people took more than. So if we've got 100 people, it would just literally be 100 minus the 80, which gives me 20. So I can now say that that's 20 people. Okay, now work out the median queuing time in minutes. So we go back to our cumulative frequency. Now we've already done this. This is why I said drop the line in. Our median, remember, is the middle number. So 50 is the middle number of 100. So we come along, we hit the line and we drop down. Now this is our median, so this is the number of minutes. Now from here to here is 5. So make sure when you're looking at a graph you know what you're looking at. So from here to here is 7.5. Okay, that makes sense. So from here to here is 2.5. So this must be 0.5, 1, 1.52, 2.5. So these are 0.5s, these little squares. So this will be 7.5, 8, 8.5, 9. Okay, so this will be 9 minutes. Okay, now there's no working out here because you've shown on your graph the median and the two interquartiles. Okay, so when you get a cumulative frequency graph, just out of habit draw in the upper and the lower quartiles, the median, then answer the questions, because at least one of them will involve this. Okay, so we'll now move on to the next part of the question. Okay, so 13C. So a new serving window is opened in the post office. The times that 100 customers spent queuing is then recorded, and the box plot shows the result. So here we have the box plot. Okay, now remember this is the median, this is the upper quartile, and this is the lower quartile. Okay, and these are the two extreme points, the minimum and the maximum. So the first question says, work out the interquartile range of these times. Now the lower quartile is hitting here, and my upper quartile is hitting here. Now we can see again that these are 0.5 steps. So this would be 2.5, so this would be 3. And our upper quartile, 10, 10.5, would be 11. So the interquartile range, remember, is the upper quartile take away the lower quartile. Okay, so 11 take away 3 gives us 8 minutes. Okay, so we have an interquartile range of 8 minutes. Now, part D, compare the queuing times before and after the new serving window was opened. Okay, so in the previous graph we had the old window and now we have the new window. Okay, so we have a median 5.56, 6.57. So we have here a median of 7. This is our median. Okay, so if we go back to our previous one, our median came in at 9. Okay, so we can say first of all that the median has decreased from 9 to 7. Okay, they're just seeing what can you see from this information. Okay, the median has decreased from 9 to 7. Okay, Now if we go back to our previous graph again, we have a lower quartile of 6 and an upper quartile of 13. So lowest from the highest, 6 from 13, gives me an interquartile range of 7. Okay. Now the interquartile range here is 8. So we can say the interquartile range has increased from 7 to 8. Okay, they just want you to make observations. That's all, nothing more. Okay, so it's literally say what you see. Nothing more complex than that. You could see other things. Here you may see that the highest value here is 15, or sorry, 17.5, and if you look on the graph it might be different. So you can just say whatever you see. You're just literally comparing the two. Okay, so we'll move on to the next question. Okay, so 14a. So here we have a triangle in a circle, so we're involved in circle theorems here. So A, B and C are points on the circumference of a circle. So we can see that all the points of the triangle are touching the circle, and A to C is coming across the centre of the circle. Okay, so this is the diameter. So the question says, work out the size of angle X. So we need to find this angle X. Now the thing I do know is that if this is the diameter and I run a line to hit the circumference and come back to the other side, this will always create a right angle. Okay, this will always create a right angle. So angle ABC is a right angle. So it would just be literally 180 minus 90 minus 55. Okay, now 90 and 55 are 145. 180 minus 145 gives me 35 degrees. Okay, it's only worth 1 mark. So not a huge amount of work to do on that, okay? But this part of the theorem is really important, that you need to know that this creates a right angle. Okay, and now we move on to the next question. Okay, so question 14b, P, Q and R are points on the circumference of the circle, so P, Q and R, and they probably want us to work out Y. Yeah. So again, circle theorems, angle Y will always be twice the angle at the circumference. Okay, this is always the case. So this would just be 2 times 50. So 2 times 50 equals 100 degrees. So I can write that in 100 degrees. Now the reason why is just literally that the angle at the centre is twice the angle at the circumference. Okay, and again 2 marks for this, so 3 marks overall for very basic circles theorems. So circles theorems are very worthwhile knowing. Okay, so again a nice simple question. Okay, so I'll stop there and then I'll go on to the next set of questions.